Hi, I thought I'd record this video, help you through. Dr. Stevens does a fantastic job of doing all this work by hand, but I want to make sure you should learn how to use those calculators, because from here on out, the calculators make things so much easier. Now, with that said, this first thing I'm going to show you isn't using a calculator. So there's three kinds of confidence intervals we're going to look at this week. Here, what do I have? So I've got one, so it's a quantitative variable. And the other thing, if this is all about sampling distributions, right? So you've always got to find, either use the central limit theorem or that proportion. You know, when dealing with proportions, some of you talked about that last, couple weeks ago before the test, and so that's where we're going. We won't be using the binomial theorem at all, really. We'll be using that normal approximation and then dealing with proportions. And you'll see with those other videos, that's not really what I want to do with this video. So this is the first problem that I wanted to do. You've got the answers in the back of the book or in the course resources, right, in Canvas. And this is about a quantitative variable of hours of sleep. And we know the population standard deviation. Honestly, we never do. Maybe it's you might for something, but the difference is here we're going to, because we know the population standard deviation, you are going to use the z distribution, okay? And because that happened, you can go look at those formulas, and I'll walk you through a couple of things. Now, one thing that always comes up that people have a hard time with is what's the point estimate? Well, we went out and did this sample, or somebody went out and did the sample of 50 college students and found their average hours of sleep was 6.2 hours. Well, that's the point estimate. Now we're going to come up with a better estimate that accounts for sampling variation, because you can go out and do another 50 samples, another 50 students, get a totally different mean, right? So we want to come up with an estimate that will capture 95% of those possible means, okay? So anyway, so the point estimate is the sample result. In this case, it's X bar, the 6.2. Now we're doing 95% confidence interval for the mean number of hours of sleep for all students. So we know a couple of things here. Let me pause this video and let me get a couple things loaded. Okay, so the general form for when you know the population standard deviation for confidence interval is this. Now, this is the margin of error, and that's your point estimate, of course. So for this sample here, can I let me come back so I can drag some stuff around. So I know that there are let's see, 6.2 and 50, and the population standard deviation 1.25. So 50, oh, this is weird. So let's see, 6.2 is the population standard deviation. And then, oh, how about that? I went to the paint. All right, let me come over here. 6.2 plus or minus. Now, that critical value of z, that z star, how do you get that? Well, I know one way he talks about showing you how to do that is to go use inside the table, but Dr. Stevens did this great little mini table down here. And this is for 95%, we're going to go 1.96 standard deviations either side of the mean. We could use 2, it'd be a really close estimate. You remember how we went 2 standard deviations for outliers either side? This is a little bit better estimate, a little more fine-tuned. So if we come back to paint here, I know my critical value of z is 1.96. Oh, so keep switching back and forth between the apps. Okay. And then to get this margin, the standard deviation, well, we know that standard deviation was 1.2 over the square root of 50. And remember, this is like that sandworm problem for the exam. So I'm just going to calculate that margin of error. I'm going to do 1.96 times 1.2 divided by the square root of 50. And that gives me a margin of error of 0.33. Let's see how many decimal places. It's always good to go one more than what you have started. So it's going to be 6.2 plus or minus 0.33. So then we're going to get the interval. So it's 6.2 minus 0.33, and that'll be my lower range. And then I'm going to do 6.2 plus 0.33, and that'll be my upper range. Now, the other thing that I want you to Dr. Stevens' WebAssign doesn't make you do too much about this. He does make it be a multiple choice, but what I want to see is I want you to see something like this where you're gonna, here, come on, give me a text, give me text. There we go. I want you to do something like this. You're going to use this kind of language. We are blank % confident, whatever percentage you have. In this case, it'll be 95% that the true, blah, 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 is between, and then you do the lower, you can say between this and this, or and this to that, that doesn't so much matter. You don't want to say too much. What you're trying to do is estimate the population mean or proportion. Okay, so in this case, I would put here, let me come back and I can write on this. So we're 95% confident the true mean hours of sleep for college students. See how it's specific that is between, I guess I can do this. What's 6.2 minus 0.33? 5.87. And as much as, I can do that one in my head, 6.53 hours, okay? So, and it's a really accurate result. I mean, it's amazing. This is magic if you ask me. But that's what you do. And for when you know the population standard deviation, we're going to use a z-score. Okay. Now there's calculators out there that you can find and use. And I'm not going to point you to any because they always are changing. And honestly, this is pretty easy and it helps you build that understanding about what the heck you're doing. Okay. Now, what if, let's go back and take a look at that. Here, let me clear off all this. You can come back and watch that. Let's go back and take a look at that assignment. Does it support the claim? Well, what was our two ranges? 6.5, 6.5. What was the other one? Yeah, 6.5 got captured in that interval. So yeah, we're good. It does support that claim. And then how do you estimate the sample size? This case, there's not a nice slick formula. There's a formula, not a nice slick calculator. And I'm going to point you to this formula, and because this gives somebody a hard time always. If you come back here, what page is it on? Here you go, on 109. So you take the critical value of z times the standard deviation divided by the margin of error, and then you square it. And then what's really important is you round up. If you don't get an integer, you'll always go up. Even if it was like 62.2, you're going to round up to 63. Because 62.2, if you just use 62, that's not big enough. You'd have to go up to the next number. Okay, so don't miss that rounding off thing. That's really, really important. And Dr. Stevens walks you through this, so I won't walk you through that formula. But just what I will point out is the rounding off. That's if you get this wrong, it's usually because you didn't round off right. I mean, yes, you could have done a arithmetic error too, but okay, so there's that. So now what happens here? Let me come back and look at some, whoops, let me come back and look at another kind of question. So this is what I've done with z distributions. Now, when you come down to the next part, when you don't know the population standard deviation, see, we don't know the population standard deviation. So this means, so there's a couple of conditions you've got to meet. Is the sample size bigger than 30? Because if the sample size is bigger than 30, then the central limit theorem kicks in, and we can use use all that stuff we did back in chapter 6 to work with this. So yeah, we got a sample here of 150, so that's fine. Plus, it's a random sample. The average student, you take a random sample. So we got a big sample size, we got a random sample, we're safe to go. But we can't use the z distribution, we're going to use the t distribution. So I'm going to, before I leave this page and show you the calculator I want you to use, it's a great calculator. Instead of having to look up all those t-scores you don't have to do that. Dr. Stevens walks you through that. And it is not impossibly hard. Let's see. So we know our random sample, our X bar is 24,000. And we know this S, the sample standard deviation, is 2,500. And how many students did 150 students, so N equals 150. And they want us to construct a 95% confidence interval. So we got a 95% level of confidence. I just remembered something I got to do for you. If you go try the open math ones. Actually this one too, but if it's a T distribution, use this calculator, and you don't even need to worry about that. So where I'm going to point you into modules. It's going to load. I'm here at school. This ought to be loading crazy fast. There's not too many of us here. Oh yeah. I want to go to course resources and online statistical tools. And then you're going to go to, let's see. Oh, this does do one. Now, I don't know if that link still works. That I don't know. But here's the one I'm going to point you to. See, this is not for Z intervals. So you want to go click on that link. And what's nice about this calculator is this does this week's work and next week's work and chapter 9 work. So, it's a nice thing to use. So we've got means. So I'm going to go with one mean. I've got 150 students. I don't even remember what it was. Was it students? The mean for those people are 24,000. Was that right? Yeah, because it was his college debt, wasn't it? Let me come back and look. Yeah, student debt, 24,000. Yeah. And then S was 2,500. Notice I don't have to do that calculation because this will automatically do it for us. Click calculate. Now we're doing a confidence interval. We want to do a 95% confidence interval. And there's the lower bound. There's the upper bound. That much easy. So then we can say we're 95% confident the true average Vermont college student debt load is between $23,596 and $8.65. I mean, good around. I mean, what's 65 cents with that much money? Or up to as high as $24,403. Okay, so that's that easy. I mean, you don't have to worry about degrees of freedom. You don't have to worry about the T-score. You don't have to worry about weird confidence intervals. I mean, what if they want us to do the 80% confidence interval? I mean, I don't know why you would. That's a pretty wide. So you just change that and it automatically does that. You don't have to go look up anything else. You just got to make sure you do that. Now, there's one thing in WebAssign. I think I've got other videos available for that. Or if you ask, I can always go post it. You can paste data in. So you can paste the data in, and it'll use the data and then it'll do it for you. Okay, it's very slick. It'll calculate the mean and standard deviation. I mean, if you're stuck with this, you go get the data off, and it'll be the red data. Go get it off of WebAssign, and well, maybe I should give me a minute here. Let me open up an example. So is this question that people always ask about, and so what you can do is, because it's a mean, it's about student debt again, so it's that same question just with the different data, and they didn't tell us the sample mean, sample standard deviation. So what we can do is go copy this data. See, notice I'm not even where I'm just getting both of them. Then I'm going to go open up a spreadsheet. Of course, I probably like Google Sheets. So one thing that happens when you're copying and pasting in data, if you double click on your sheet and paste it in, you see how it dumps it all in one cell? That's not helping us. So what you do is, if we just click on the cell once, and then it'll copy in nicely. Now, we don't care about the student number. All we want is that data. That red data that's been randomly generated for each of you. So I'm going to copy that. I'm going to come back to that Rossman Chance. Dave Rossman, I don't remember his first name. Beth Chance was a professor at Dartmouth. Maybe she still is. They did a fantastic book. I used it for a couple semesters for CCV. It just didn't lend itself well for the online environment, so I stopped using it. But it worked great for the classroom. I still use parts of it in my Oxbow statistics class. So see what I did is I pasted in that data. I clicked use data. There's the mean. There's the standard deviation. We want, what do they want us to do? A 95%? Here, no, I don't want to edit this time. I don't want to look at it. They want us to come up with a, they want us to do a 95% confidence interval. See, I mean, I'm at school. So you just come back here, the applet, make sure you click confidence interval, right? We aren't doing significance tests yet. And you do and that's the t-test. That's the one sample t interval, I mean. And so we're 95% confident that the true debt based on this data, this sample is for Vermont students between those two numbers. And then I want to come back and look at Web of Science, see what they ask us for this, because they do some great, Dr. Stevens does ask some great questions. Are you confident that the Vermont college students are greater than the quoted national average? Well, let's go back and look at our interval. Our interval says 23 and the national average was 22. So, oh yeah, because that national average is not captured by our interval. Looks like Vermont students, at least based on this data, that they would have higher debt load in the States or in Vermont. Okay, so see how easy that I encourage you to do this. On a test situation, you just got to screen capture that, paste it in your tests for me. Okay, you don't have to do any of the degrees of freedom or anything like that. Okay, so that's that. Now, the only other thing I wanted to show you is how you do, and how you do proportions. Where is that? Summary problems. Is this the one? No, that's still. I think I must have scrolled by the proportion. There's a population mean. Oh, did I do, is the proportion, oh, here's the pinworms, right? Oh, well, I won't leave that. I'll let you do that one. Here's the corn earworms. Oh, that's fantastic. I digress. Roasted corn is the best thing, huh? Anyways, so we did a random sample. I'd be very interested to see if I've got a student this spring or this summer that Dr. Stevens is her uncle. I would be very interested to ask her if Carl, if he knows that her uncle knows a farmer Carl. But that's one bad thing about working online, teaching online. I don't get that kind of interaction. But anyways, so so what we're going to do here, and this is where it's a little different than binomial distribution. We have x equals 12 and we have n equals 80. So what's our point estimate? Well, our point estimate is just this p hat, this sample proportion. So we're trying what proportion of, see, unlike when we do that normal approximation, the binomial distribution, where you're coming up with a number, here we're coming up with an actual, like a percentage. So p hat equals 12 over 80, which I think is, no, I don't know. Let's see, divide them both by 4. That's 3 over 20 and times it by 5 to get to 100. I know I could grab a calculator. So that's 15%. Okay. So we're going to come up with 15% based on the sample. 15% of Carl's corn has earworms in it. And so now we're going to come up with some confidence intervals. And what's beautiful about that Rossman chance, now this is a DZ distribution. You could go back and use that Z table. However, we don't have to. Let's see, do I have that written down? So I'm going to do a 95. I want to do a 99. And then they do that sample size calculation. Dr. Stevens does a fantastic job of that. So I'll let him do that. But I wanted to show you how to use this applet. So I'm going to come back to Rossman chance. And what's going to happen here is you're going to select one proportion, because this is about a one proportion. And we don't have any data to paste in. So he did 80 years of corn, and 12 of them had earworms. See how it does the p hat for us. And then you click confidence interval, 95%, click calculate. And of course, those are proportions. So you could say, make them percentages and say 7.2% to as high as 23% or something like that. I mean, the rounding is the issue to keep the computer happy, right? But that's our 95%. So we'd say 95% of all of Carl's corn has so we're 95% confident that between 7.2% to as high as 22.8% of Carl's corn has earworms in it. And that's what you do. And now what if they want to do the 99? Well, you just go back here, change that to 99, calculate it, makes it a little wider, right? A higher level of confidence in keeping your sample size the same means it's a wider margin of error. You need a bigger margin of error. Okay. How do you get the margin of error? What if the problem asks you for the margin of error? Well, we know that, and you're using this calculator, we know that it's going to be p hat or x bar plus or minus some margin of error. And we know that p hat minus the margin of error is there, and p hat plus the margin of error is there. So if you wanted to, you could say, hey, we got 0.15%. So 0.15, so minus 0.047, that number would be the margin of error. You could also say 0.15 plus, no, actually we don't want to do plus because that's how you do it. So it would be 0.2528 minus 0.15. That's how you'd get the same. These should give us the same values. Okay. You don't even have to worry about p hat because know how this is two margin of errors wide, right? I subtracted a margin of error to get that lower bound. I added a margin of error to get that upper bound. I could just do it this way. I could just take the 0.2528 minus 0.0472 and divide that by 2, and that would give me one margin of error, which would be the same as this number, which would be the same as this number. Okay, so there's a couple of ways to do it. And it works for means and it works for proportions. Okay. I think that's it. I think that's all this, as long as this video needs to be. Here to help you folks. Give a yell if you need some help.